Let's read the problem below, then explore whether or not the expressions are equivalent. Ms. Liam asked her class to find an expression equivalent to. I'm just going to read the numbers. I'm not going to read them in the order they should be read, but I'm going to read the numbers from left to right. 7 minus 3 times 4 minus 2x minus 10x. Remember, order of operations matters. One step in each of the following students' work is incorrect. Find and explain the error. Then write your own expression equivalent to the one given above. And there's a reason I didn't read it in the order it should be read, so you don't get a clue. Let's see how you do. So here's John's work. Remember, one step in each of the following students' work is incorrect. So you need to see where John made a mistake. So please look at that. I would pause the video to look at that, and then let me show you the two other students, Madison and Selena. Notice there's an X at the bottom, means they made a mistake. It's your job to find the mistake they made. Again, pause the video and see what mistake they made. Now let's connect it. Now you'll think about properties and the order of operations to solve them. John didn't follow the order of operations. Explain what he did wrong. Madison made a mistake when she combined terms. Explain what Madison did wrong. Selena didn't use the distributive property correctly. Where did she go wrong? Explain your thinking. Write an expression that is equivalent to 7 minus 3 times 4 minus 2x minus 10x and show your work. How can you be sure you've used the properties of operations correctly to form an expression that is equivalent to the original one? So again, pause this video, solve these problems to help you, and then when you unpause, we will go over these questions one by one and see where you're at. Now let's check the answers. Let's see what John did wrong. John subtracted 7 minus 3 before multiplying. So when you look down here, order of operations does matter. You cannot subtract before you multiply, or in this case, distribute. So that's the mistake John made. Madison, the mistake she made, 4 and 2x are not like terms. And Madison incorrectly combined them. Let's look at Madison. As you can see here, she did 4 minus 2x and got 2x, but these are not like terms. If this was 4x, then they would have been like terms, but it's not. Let's look at Selena. Selena didn't use the distributive property correctly. Where did she go wrong? And explain your thinking. Well, Selena should have multiplied both the 4 and the negative 2 by negative 3. She forgot to multiply negative 2x by negative 3. Let's look at that. This is a common mistake that a lot of students make. When you distribute, you have to share the love, as we say. So if you look down here, 3 times 4, or negative 3 times 4 is negative 12. And then she did not do negative 3 times negative 2x. She just left it as negative 2x. Can everybody see that? Let me do it again so you guys can see it. I'll do it from above. First thing you need to do is the 3 times 4, and you got the negative. So it's kind of like negative 3 times 4, which is negative 12. And then you're supposed to distribute to this term, negative 3 times negative 2x, which will make it positive 6x. And that's what she did not do. Okay, as you can see, again, Number 12, write an expression that is equivalent to this one. So again, I'm hoping that this is what you got. Negative 5 minus 4x. This is the final answer. And for those who didn't do it or get that, let's break this down. First thing I need to do is distribute. Alright, I got the 7. Negative 3 times 4 is negative 12. I'm going to distribute negative 3 times negative 2x, which gives me positive, right? Negative times negative is positive. 3 times 2x is 6x. And then I got minus 10x. Okay, that should be the first step. Now let me see the like terms. 7 and negative 12 are alike. And then you have 6x is like with negative 10x. So now let's simplify them and see what we got. Let me do something thicker and use black right now. So 7 minus 12 will give me negative 5. Right? And then 6x minus 10x will give me negative 4x. And there's my final answer. You can also write it as negative 4x minus 5. Right? Those are the two terms, negative 4x and negative 5. So there's your answer. Hopefully that was helpful. If it wasn't, you can always go backwards. Stop this film and go back, and then you can see that again. And now number 13. One of the possible answers, because there could be plenty of possible answers, I could evaluate both expressions for some number and see if the results are the same. I mean, that's the key. So again, I can evaluate both expressions for some number. That means plug in a value for x. Like let's say 2. When you plug in 2, you solve it out. Then you plug in 2 here, and you solve that out. You would have negative 5 minus 8, which equals negative 13. And if you plug it here, you'd see it'd be the same thing, because it'd be 7 minus 3 times 4 minus 2 times 2, right? Minus 10 times 2, right? Because it's x. Okay, let's do this and let's do that. Alright, when we solve these out, this will be 0, and then you get 7 minus 10. Am I going too fast? Maybe. Let me go back and break it down even further so we can see this. That's what happens when you rush. Even we make mistakes. So let's do this out. 3, 4 minus 2. Remember, for the value of x, we're going to say 2. Okay. And then minus 10 times 2. Okay. So now we can distribute, or we can just do what's in parentheses first, order of operations. Negative 2 times 2 is negative 4. Okay. And then let me rewrite this. Minus 10 times 2. And now 4 minus 4 is 0. I still have the negative 3. 7 minus 10 times 2. Negative 3 times 0 is 0. 7 minus 0 minus 10 times negative 2 is 20, right? 10 times 2. Negative 10 times 2 is negative 20. 7 minus 0 minus 20 is negative 13. Okay, if I'm going too fast, I apologize. And down here it's the same thing. Negative 5 minus 4 times 2. And 4 times 2 is 8, but negative 4 times positive 2 is negative 8, and negative 5 minus 8 will give me again negative 13. Okay? That's how you can check your work for question 13. Now let's see if you can try this on your own. Numbers 14 and 15. Okay? Take your time. Number 15 looks like it's confusing. Don't let the fractions or mixed numbers confuse you at all, focus. But use what you just learned about equivalent expressions to solve these problems. Please show your work on a separate sheet of paper, or obviously on this paper, as long as it's nice and neat. Pause this video, and once you unpause, we will go through the answers. And here we go. Let's see what we got for an answer. So hopefully, the first one, the answer is no. So it says, is negative 8 minus 2 times 3 plus 2n plus 7n equivalent to negative 30 minus 13n? And the answer is no. Use the distributive property. Okay, negative 8 minus 6 minus 4n plus 7n, and then combine like terms, negative 14 plus 3n. So, negative 8 minus 2 times 3 plus 2n plus 7n is equivalent to negative 14 plus 3n, but not to negative 30 minus minus 13n. So let's do this out. Okay, I'm going to rewrite the problem here, step by step. Okay, and the way I read it, obviously, is not the way you should read this. You should always read this in the order of operations. You should say 3 plus 2n times negative 2. Okay. You could say plus 7n minus 8, or you can say 3 plus 2n times negative 2 minus 8 plus 7n. Alright, let's see what we got here. First thing I'm going to do, distribute. Negative 8 stays negative 8. We're not doing anything with that. Negative 2 times 3 is negative 6. Negative 2 times positive 2n. Negative times positive is negative. 2 times 2n is 4n. Okay? And then I'm going to add the rest. Now I got to look at the like terms. And I like to use different colors for the like terms. Negative 8 and negative 6 are like terms. Together they combine to make negative 14. Alright. And then the other ones, negative 4n plus 7n, will give us positive 3n. So, oops. Let me try that again. Positive 3n. So, final answer is negative 14 plus 3n, or you can say 3n minus 14, right? Because those are the terms. So obviously, clearly, it's not negative 30 minus 13n. So for question 15, the answer is yes, they are equivalent when you simplify them. I can use the commutative and associative properties to write negative 1/4 y plus 2 1/4 y minus y, and then plus 2. Next, I can combine like terms to write y plus 2. So when you look at this expression, okay, let me rewrite that here. Negative 1/4 y plus 2 1/4 y plus 2 minus y. What I'm going to do is just combine the like terms. Negative 1/4 y plus 2 1/4 y minus y. Okay? Negative 1/4 plus 2 1/4 will give me positive 2. So now I have positive 2y plus 2 minus y, right? And then if I take, and I'm going to take these like terms, notice I'm doing it step by step. 2 minus 1 will give me 1. So it's 1y, and then plus 2, because 2 is constant. I hope this makes sense. If you get stuck with the fractions, I would go back and review some of those fractions. Okay, but negative 1/4 plus 2 1/4. Okay, we have like terms here. We can take this and make that into a mixed number. An improper fraction. 4 times 2 is 8 plus 1 is 9 over 4. Right? There we go. Now we have like terms. Negative 1 plus 9 is 8 over 4, which gives me 2. So there's a small example of how we take 1/4 plus 2 1/4 to make it 2. Hope this helps.